everyone. Today we are going to continue with our discussion of SohCahToa. In the lesson that we did last time, we needed to use our warm-up. We had discussion notes as well as our examples packet, and we will need all of those materials again. So if you wouldn't mind having out your warm-up from the last lesson, the discussion notes that you've printed out, as well as your examples that we learned about and used yesterday, that would certainly help us out. You will also need a calculator. It does not matter if it is a graphing calculator or a scientific calculator. And you will need colors. We use colors as we are working, and it is really important for you to be able to differentiate between different sides and information that is given to you. So the first thing that we are going to do today is look back at this warm-up. And in this warm-up, we reviewed methods that we have already learned about. We reviewed Pythagorean theorem and working with special right triangles. We had two different types, 45, 45, 90 and 30, 60, 90s. But then we kind of got stuck when we got to examples 4, 5, and 6. Most of us were not able to necessarily complete those examples on our own. And that's where I told you that mathematicians were not able to do those types of problems. And they came up with 3 new operations called sine, cosine, and tangent. And in our lesson from yesterday, or not necessarily yesterday, in our last lesson, we learned that SohCahToa, sine, cosine, and tangent represent fractions. And those fractions are sine of an acute angle is equal to opposite over hypotenuse. We call that SOH. Cosine of an acute angle is equal to the adjacent side over the hypotenuse, which we call that CAH. And the tangent of our focus angle is equal to opposite over adjacent, TOA. And we use the mnemonic device SohCahToa to help us remember those ratios. And that was that the sine of our angle that we're talking about, so if we're talking about angle A, that is going to be equal to opposite over hypotenuse. And the cosine of angle A would be equal to the adjacent side divided by the hypotenuse. And the tangent of angle A is equal to the opposite side divided by the adjacent side. So we learned all of that in our last lesson. And we also remembered that the way to remember it is using the phrase SohCahToa. All right. So now what we're going to do is we're actually going to be answering these questions. So what I have here in this next little item is that we have used the Pythagorean theorem as well as special right triangles to find missing side lengths of right triangles. We use that when we know 2 other sides. So out of our 3 sides of a triangle, we know 2 of them. And if you know 2 of them, you use Pythagorean theorem. But, the key word here is but. What if we only know what one side is and what one acute angle is? So when we say one angle, it means that you know that it's more than just a right angle. You know the right angle and one other angle. We can now use trig ratios, sine, cosine, and tangent are your trig ratios, to find the length of a side of a triangle in these cases. So what you're going to see in these types of problems, and I'm going to write this down right here, is you will see the following. And when you see the following, you know that you'll be working with SohCahToa. You will see a picture of a triangle, and that triangle will be a right triangle. So that is number 1. You will see a right triangle. And you know it's a right triangle because it'll have the right angle symbol in it. The next thing you're going to see is you're going to see that it is not 45, 45, 90, or a 30, 60, 90 triangle. In other words, it's not special. So it's not one of our special right triangles. It'll have some other angle in it, like 36 degrees. This is just a quick example. You will also see that you are given one acute angle. So one acute angle is given. And you are given one side length. So one side length is given. For example, we'll say that this is 84 feet. And you will be asked to find the other side lengths. We might use letters like X and Y to find those side lengths. And what you're going to use is you're going to use SohCahToa in order for you to find the missing side lengths. All right, let's go back to our warm-up. Notice that in our warm-up, we have in number 4 an angle, 59 degrees. It is not special because 59 degrees is not the same as 60 degrees. We are given one side length, and we are asked to find a missing side length. We also see that this is a right triangle. So in order for us to find this, we need to use the trig ratio of SohCahToa. So I'm going to write at the very top SohCahToa, which we already have it right here, but I'm going to write it again because it's always helpful to write down SohCahToa. And I'm going to identify the information that's given to me based on my focus angle. So 59 degrees is my focus acute angle. And the X is across from it. It is opposite of my focus angle. And because it is opposite, I'm going to write OPP. The other information that's given to me is 17. And 17 is across from the right angle. And that is my hypotenuse. So when you're asked to find what X is, you need to figure out, should I use sine, cosine, or tangent? Well, that just depends on the information that's given based on our focus angle. And based on my focus angle, I am asked to find the opposite, and I am given the hypotenuse. So what uses opposite and hypotenuse? SOH. So I'm going to write that the sine of 59 degrees is equal to a ratio. That is the ratio of my length of the opposite side divided by the length of the hypotenuse, which is 17. Now, if you were to put into your calculator sine of 59. Now this is 59 degrees. We have a degree symbol here, and our calculators have different modes. So it's imperative. It is really important that your calculator is in degree mode. So if you're using a graphing calculator, at the very top next to second is the word mode. Please click on that. And what you're going to see right here is the word radian and the word degree. Radian is a special type of degree, a special way that we can express angles, and you learn about that in Algebra 2 or Algebra 2 with trig. You will not learn about that in this class. So instead, what I need you to do is press the down arrow until you reach radian and press the right arrow so that it says degree. It's going to be blinking, and you'll press enter, and that will transition your mode from radian to degree mode. Likewise, in a scientific calculator, you'll see the words or the letters DRG. In this type of calculator, it's located at the top. In other calculators, it might be located in a different spot. But if you click on, so let me turn on my calculator. If you click on DRG, you want the DEG, meaning degree, to be underlined. You don't want the other ones to be underlined. You need it to be in degree mode since all of our angles will be in degree mode. And the reason I'm bringing up our calculator is what I want to emphasize is that the sine of 59 degrees, remember sine is a function. It does something to numbers, to angles. It represents a fraction. And if I were to put the sign of 59 into my calculator, it represents a number. And so because sign of 59 represents a number, I can use cross product by making this over 1 in order for me to solve for x. So I'm going to use our methods that we've learned before in order for me to find what x is. So I'm going to write the sign of 59 over 1 is equal to x over 17. Cross product means 1 times x is x. And this equals 17 times the sign of 59. And I'm going to put this whole expression into my calculator exactly as I see it. So I'm going to write 17 times the sine, which down here we have sine, cosine, and tangent, right here, sine, cosine, and tangent, and I'm going to put in sine of 59. Pressing enter, my answer is 14.57. So the length of x is 14.57, and I am done. There's nothing more for me to do to find that length. And that length makes sense because it needs to be shorter than the hypotenuse, and it certainly is. Let's go ahead and look at example number 5. 27 degrees is not special. It's not 45. It's not 30 or 60. I also am told that this is a right angle. And so 27 degrees will be my focus angle. X touches that angle, and that is going to be my adjacent side. 20 is across from the right angle, meaning that this is my hypotenuse. So if I wanted to find what the adjacent side is, I'm going to come up here and I'm going to use CAH, cosine, because I am given and I know information about the adjacent and the hypotenuse. So I'm going to write that the cosine of 27 is going to be equal to the adjacent side, which is x, divided by the hypotenuse, which is 20. Now, cosine of 27 is a number, and you can put it into your calculator to see that it represents a number. I don't know what that number is. I mean, it's a decimal that goes on forever and ever, but because it represents a number, I can make that number over 1 and do cross product in order for me to find what x is. So this is 1 times x, which is x, equals 20 times the cosine of 27. And I can put this expression into my calculator exactly as I see it. And just for fun, I'm going to use the scientific calculator. And I'm going to write 20 times the cosine of 27. Enter. I end up with 17.82. Which that makes sense. 17.82, that's as a leg, and it should be shorter than the hypotenuse. So that does make sense. Next, 40 degrees is going to be my focus angle. This is a right triangle. 40 is not 45, 30, or 60, so it's not a special right triangle. It's just a regular right triangle. And 20 is across from 40 degrees, so this is my opposite side. X touches the 40-degree angle, and this is my adjacent side. Notice that I have no information about the hypotenuse, so I'm not going to work with the hypotenuse in this problem. Instead, I'm going to come up here to SohCahToa, and I know that I have O and A information, so I'm going to be working with TOA, tangent, which means that the tangent of my focus angle, which is 40 degrees, is equal to opposite, which is 20, divided by the adjacent, in this case is x. Tangent of 40, once again, represents a number. I can put tangent of 40 into my calculator and get a number. Now, that number is going to be a decimal that continues forever and ever. I don't know exactly what that number is, but I do know that it represents a number, and I can make this over 1 and do cross product. So I end up with x times the tangent of 40 is equal to 1 times 20, which is 20. Well, I need to get x alone, so I'm going to divide both sides by the tangent of 40, which remember that's just a number. And those two will cancel away, leaving me with x equals. And I'm going to put it into my calculator now. Please be careful. This is 20 divided by the tangent of 40. And I end up with 23.84. 23.84. And there is my answer. All right, you guys, please go ahead and flip back to our examples packet. Notice that I have on here for our examples that your calculator needs to be in degree mode. So it is very, very important that you do that. And the problems that we just did in this warm-up, we were just trying to identify what one side is. And in this type of problem, we want to identify what two sides are. So you want to just go one step at a time and identify your focus angle. And in this case, my focus angle is going to be 44 degrees. And we want to round our answer to the nearest tenth. If it doesn't say so, round to the nearest hundredth or round to whatever it says. But typically we do rounding to the nearest hundredth, but in this problem it's going to be round to the nearest tenth. In 44 degrees, I want to find what x is, and x represents the opposite side. Notice that I always label. I really recommend that you always label 2. That will help you to stay organized and figure out what you're working with. I would also write SohCahToa at the very top, just so that you have something to refer to whenever you're making decisions. 14 is across from the right angle, so this is the hypotenuse. So what uses opposite and hypotenuse? That is sine. So I'm going to write the sine of 44 is equal to opposite, which is x, divided by the hypotenuse, which is 14. I'm going to make the sine of 44 over 1, and I'm going to do cross product. So I end up with x is equal to 14 times the sine of 44. And I'm going to put 14 times the sine of 44 in my calculator. And when I do that, I end up with 9.7 is my answer. Next, I need to identify what y is, and y actually touches the angle. So therefore, this is the adjacent side. So I'm going to be working with cosine. So I'm ignoring the opposite, and I'm just going to be working with given information. So I'm going to actually write that down as a little note for you guys to always use given information. The reason why I say always use given information is, what if you made a mistake back here with x? What if you got something else other than 9.7 and you were to use tangent instead? Opposite over adjacent, I now know that the opposite side is 9.7, and I were to come up with what y is. Well, your answer right here might be incorrect. It's not in this problem because you did it with me, but when you're doing it on your own, you might make a mistake. And so therefore, I'm strongly recommending that if it's not avoidable, please use given information. So I am ignoring the opposite side, and I'm working with adjacent and hypotenuse, and that's going to be cosine. The cosine of 44 is equal to the adjacent side, which is y, divided by the hypotenuse, which is 14. The cosine of 44 is a number. I'm going to make it over 1 and do cross product. 1 times y is y, and that's equal to 14 times the cosine of 44. And I'm going to put 14 times the cosine of 44 in my calculator, and I end up with 10.1 as my answer. Here you go. All right, the next page has a bunch of problems that are very similar to the problems that you have just received. So if you would like to pause the video and try some of these problems on your own, please go ahead and do so. Some of these numbers are really challenging to read. This number right here is the number 11. This number is the number 18. I think everything else is pretty visible. This is 14 if that helps you, but I know that this came out a little faded, so I'm just putting it out there. what some of those numbers are. So once again, please go ahead and pause the video and try to complete these problems on your own. And when you're finished, go ahead and check back with me and we'll see if you got them correct. All right, here we go. For this first problem, letter A, 36 degrees is my focus angle. I want to find x. X is the opposite. I am given the hypotenuse. That means I'm going to be working with sine. So I'm going to write that the sine of 36 is equal to x over 11. I'm going to make this over 1 and do cross product. I end up with x is equal to 11 times the sine of 36. And when I put that into my calculator, I end up with x is equal to 6.5. I'm rounding all of my answers to the nearest tenth. For letter B, 65 degrees is my focus angle. X is the adjacent side. 18 is the opposite side. So therefore, I'm working with tangent. And if it helps you to put SohCahToa at the top, please go ahead and do that. So I'm going to write the sine of opposite adjacent. That means I'm working with tangent. The tangent of 65 is equal to opposite, which is 18, divided by the adjacent, which is x. I'm going to do cross product, and I end up with 18 is equal to x times the tangent of 65. I'm going to divide both sides by 65, or the tangent of 65, excuse me. And when I do that, I find that x is equal to 8.4. For letter C, 57 degrees is my focus angle. 14 is the adjacent side. X is the hypotenuse, which means I'm working with cosine. So the cosine of 57 is equal to the adjacent side, which is 14, divided by the hypotenuse, which is x. I'm going to make the cosine of 57 over 1 and do cross product. So I end up with x is equal to, x times the cosine of 57 is equal to 14. I'm going to divide both sides by the cosine of 57. And when I do that, I find that x is equal to 25.7. Next, for letter D, 31 degrees is my focus angle. 17 is the opposite side. X is the adjacent side. Opposite and adjacent means that we're going to be working with tangent. The tangent of 31, that is equal to opposite, which is 17, divided by the adjacent, which is x. I'm going to make the tangent of 31 over 1, and I'm going to do cross product. I end up with x times the tangent of 31 is equal to 17, dividing both sides by the tangent of 31. I find that x is equal to 28.3. Next, 42 degrees is my focus angle. X is the opposite. 52 is the hypotenuse because it's across from the right angle. Opposite and hypotenuse means that we're going to be working with sine. So I'm going to write the sine of 42 is equal to opposite, which is x, divided by the hypotenuse, which is 52. I'm going to make the sine of 42 over 1 and do cross product. When I do that, I find that x is equal to 52 times the sine of 42, and therefore x is equal to 34.8. And finally, I am given 29 degrees. 18 is the adjacent side. X is the hypotenuse. What uses adjacent and hypotenuse is cosine. So the cosine of 29 is equal to the adjacent, which is 18, divided by the hypotenuse, which is x. I'm going to make cosine of 29 over 1 and do cross product. I end up with x times the cosine of 29 is equal to 18, dividing both sides by the cosine of 29. I find that x is equal to 20.6. And that is the end of today's lesson. Hopefully you found SohCahToa and the problems for finding missing side lengths to be relatively easy. And you've noticed a pattern that we're using over and over again. You have a worksheet for you to complete that corresponds to this lesson. And I hope that you complete it. If you have any questions on either the lesson or the assignment that corresponds to this lesson, please feel free to email me and let me know whatever questions that you guys have. Otherwise, I hope you have a wonderful day.